Okay, so let's begin. Today we're going to be doing primes, HCF and LCM. Okay, so primes are basically prime factorization, but in prime factorization we have two sorts of things. We have prime factors, the second thing we have is factors. Both of these are separate things and they're entirely separate concepts as well. Prime factorization is simply like, for example, prime factors of 48. So it would be very simple. All it would be, you would divide 48, keep on dividing it by prime numbers, like for example 2, or we all know prime numbers are 2, 3, 5, 7, 11 and 13 and so on. You'll keep on dividing it by prime numbers till you get 1 at the end. So it's basically like breaking down 48 and dividing it by prime numbers. Got it? The next thing we have is factors of 48. So this is nothing like prime factors. Factors are simple, although they have similar names, but factors are something else. Factors kya hote hain? You pick out a pair of numbers, two numbers that would multiply to give you 48. Like for example, 1 times 48, the answer is 48. 2 times 24, the answer is 48. So pair of numbers that give you, when you multiply them, give you the answer as 48. Those are going to be the factors of 48. 3 times 16, 4 times 12, 6 times 8. All of these are factors. 1, 2, 3, 4, 6, 8, 12, 16, 24, 48. All of these are factors of 48. Whereas when you divide 48 by prime numbers and you multiply these numbers all over again, that will give you the answer as 48. Okay, let's try a question. Let's try to find the prime factors of 36 and the factors of 36. Let's have a look. And the factors of 36. First of all, when I'm wanting to find the prime factors of 36, iska bahut simple sa and easy sa. There's a trick. All you need to do is, this is 36. I need to figure out what's the smallest possible prime number. That's going to be in this case 2. ठीक है, and I'm going to divide it. So 36 divided by 2 is 18, and that comes here. Then what are the prime number? Once again 2 can be divided again, so that's going to give me 9. Now 9 is no longer divisible by 2, so I think 3 is yes. 9 is divisible by 3 and 3 is a prime number, so that will give me 3 and then another 3 to give me 1. As soon as you get 1 at the end, your answer is complete. So 2 square times 3 square is a prime factorization of 36, okay? Or you're basically breaking down 36 into its prime factors. And if you multiply again, 2 times 2 is 4, 4 times 3 is 12, and 12 times 3 is 36. Now if I find factors of 36, all I need to do, iska bahut simple sa trick hai, you need to find two numbers that multiply to give 36. Jiska sabse easy, sabse first wala hota hai 1 times 36. Secondly, 2 times 18 is also 36. Now 3 times 12 is also 36. 4 times 9 is 36. Okay, 5, not at all 5 because there's no 5 or 0 at the end of 36. 6, yes, 6 times 6 is 36. When you notice that the numbers are now going in a direction like this, that the ink started to decrease, there's a back, in this case it's just the same, so these are going to be the factors. So 1, 2, 3, 4, 6, 9, 12, 18 and 36 are all the factors of 36. Simple and easy. We use prime factorization to help us find HCF and LCM, and just finding factors of a number can help us later on in middle term breaking and many other things. Okay, so we're done with that. Let's move forward. Now coming to the concept of HCF and LCM. What is HCF? What is LCM? Let's have a look. HCF is the highest common factor and LCM is the least common multiple. Now there are two ways to find HCF and LCM, both being separate. Both are as efficient when it comes to the type of question. Let's say they directly give you, let's say, a number, find the HCF and LCM of 45 and 60. All you need to do is, for HCF, you put both the numbers in one sort of ladder and you divide. It doesn't matter which number you divide them by, they just have to be prime numbers. The order doesn't matter. It could be in ascending order, it could be from small to big prime number or big to small prime number, that doesn't matter. Okay, you divide both the numbers by such a number, just say both divisible or not one, just both. So for example, 45 and 60, the first number that comes to my mind is 5. Okay, so you divide it, you get 9, 12. Now once again, 9 and 12 are both divisible by 3. So I divide by 3 again, I get 3, 4. Now 3 and 4 are not divisible by any same table. Okay, अगर किसी same के साथ होता है, I would continue the process, but no, it's not. So we stop right here, times the numbers that we have on the side. So that's 5 times 3 is 15. So the HCF of 45 and 60 is going to be 15. Clear? Moving on to the LCM. LCM is exactly the same until unless you're left with numbers like this, which are no longer divisible by the same table. So isme all you're going to do is, you're going to now, your goal in LCM is that you need to have a 1 and 1 at the end. So you will now start dividing, even if one of them is not divisible, you'll divide them by a number, ताकि you can slowly make one of the numbers come down to 1. Then I see 1, 4, 4, 2. That's a prime number. I'm going to divide it. I'm going to get 1, 2. Then 2 again. I'm going to get 1, 1 because 2 divided by 2 is 1. So that's it, and we're done. So for LCM, you just keep on dividing until you get 1 at the end. But on the other hand, HCF ke liye, all you do is you only divide until the time that both numbers are divisible by the same thing. Okay, same prime number. Let's have a look. Let's try finding the LCM and HCF of, let's see which number, LCM and HCF of 18 and 24. 18 and 24. Now what we're going to do is, first of all, we're going to make a separate sort of ladder for the we can find the LCM first, it doesn't matter, for the LCM, and that's going to 18, 24. Now for LCM, as discussed earlier, we're going to keep on dividing until and unless, okay, we can until and unless we have 1 for both the numbers at the end. Okay, so first of all, 18 and 24, let's divide them by the common number. I think 2. Yes, 2. So 2 times 9 is 18 and 2 times 12 is 24. Now 9 and 12, both are divisible by 3. So I'll just divide by 3. 3 times 3 is 9 and 3 times 4 is 12. Now 3 and 4 are no longer divisible by the same table. So I can choose 3 now and just divide 1, 4. Okay, okay. Then I need to make, we already have 1 for one of the numbers, but दूसरे को भी we have to make 1. So we'll divide by 2 prime numbers only. This will become 1, 2. Another 2, so 1, 1, and our answer is achieved. Not yet. The working is done, but the answer is not here. You're going to multiply all of these numbers and get the answer. So 2 times 3 is 6. 6 times 3 is 18. 18 times 2 is 36, and 36 times 2 is going to be 72. So the LCM of both of these numbers is 72, and we're done. That's it. That's how simple it was. Try to not use the calculator at this point, because usually questions like these arise in the non-calculator paper, so we should get our non-calculator skills working as well. Next up, for HCF, let's suppose, this doesn't happen in the CIE, they never give you LCM and HCF of the same numbers, but let's suppose you're lucky and they ask you to find the LCM and HCF of same numbers. You can also deduce the HCF इसी table से. All you need to check is till which point have you been dividing by same numbers. The first one, same numbers, we divided it 18 and 24 by 2, both of them were divisible. Then 3, once again 9 and 12 both were divisible. So यहाँ तक ठीक है, till 2 and 3 both of them were both the numbers were divisible by the same number. So 2 times 3 will give us 6, and 6 is the HCF. But if let's suppose you have to do the working separately, let's have a look as well. Not very hard. Okay, we're going to write 18 and 24 in our ladder. Okay, both the numbers, they are divisible by 2 first of all. So 9, 12. Then 9 and 12 both divisible by 3. So 3. So 3, 4. Now that 3 and 4 are no longer divisible by any same table, we stop right here and we times the number which we have left here, which is going to be 6, and 6 is the HCF, and we're done. ठीक है. This is the method in the cases where you have the numbers given. ठीक है, आपको कोई भी उन्होंने 2 numbers दिए हुए हैं, 3 भी दिए हुए हैं. Okay, you have the numbers given to you, you find the LCM and HCF using this sort of ladder method. Very easy and very simple. ठीक है, not hard at all. Then comes the case कि let's suppose they haven't given you the numbers. They have given you the prime factors of those numbers, and now we're on a time crunch always in the paper, so we have to be as efficient as possible. So in that case, what you do is, okay, and one more thing, please remember only to divide by prime numbers. Do not go on to divide by 4 in this table, or let's say 6, because those are not prime numbers, only prime numbers. Okay, you can only divide for HCF and LCM by prime numbers. Let's suppose there's a case where you have to find the HCF and LCM, but you're given prime factors instead. Like let's say they say A is expressed by the prime factors 2 cube times 3 and B is expressed by 2 square times 3 square. ठीक है, इस case में what would you do? Once again, we have to be efficient. So in this case, what you do is for HCF, you first of all expand all the numbers. So instead of putting them in index notation, you expand them, ठीक है, and 2 times 2 times 2 times 3, and then for B it would be 2 times 2 times 3 times 3. And what you do is you simply make pairs, okay, pairs of like numbers. So there's one pair here, one pair here, and one pair here. You pick one number from each pair and that gives you the HCF, ठीक है, one number. So I pick 1 2 from here, 1 2 from here, and 1 2 1 3 from here, multiply them, I get 12 at the HCF. For LCM, all you do is it's basically the HCF times by the lonely numbers जो किसी भी pair का part नहीं बने. You pick them and multiply them with the LCM, and that the HCF, and that gives you the LCM, ठीक है. But this is efficient working over here only. Okay, let's suppose your numbers are given and you try this method. It's a longer route and more wastage of time. We don't want that. So let's say you only have prime numbers, then you can go with this method. You can make the groups, you can make the pairs for HCF, and for LCM आपके जो HCF होगा उसको आपने जो numbers रह गए होंगे which couldn't be part of a group, you're going to multiply it with the HCF and you're going to get your answer. Clear? Let's try it. Let's try it with this example. Let's copy this and take it and let's have a look. We have a case right here where we have to find the HCF and LCM. First of all, मेरा पहला goal होगा to write both the numbers. A is a number which I don't know. I can find, but I don't want to waste my time in expanded form. So 2 times 2 times 2 times 7, and B is going to be 2 times 2 times 3 times 7. ठीक है? First of all, we're going to do the HCF. ठीक है? First and foremost, for the HCF, what I'm going to do is I'm going to make pairs of like numbers. ठीक है? So let's say I have a pair of 2 and 2. बिल्कुल. I have another pair of 2 and 2, and I have a pair of 7. Correct? So the HCF, you're going to pick one number from each pair. हर pair से आपने एक number उठाना है. 2, another 2, so times by 2, times by 7. So 2 times 2 is 4, and 4 times 7 is 28. So the HCF is going to be 28. But wait, we're not done. हमने LCM भी ढूंढना है. कोई मुश्किल बात नहीं. For LCM, least common multiple, what you're going to do is you're going to pick up the HCF, which is 28, and times it by उन numbers से multiply करेंगे जो रह गए, which couldn't be part of any pair, which is 2 and 3. So times by 2 and times by 3. 28 times 2 is 56, and 56 times 3 we can do on the side. Once again, practice your non-calculator skills, very important. 3 times 6 is 18, so 8 here, 1 up. 3 times 5 is 15, plus 1 is 168, and that is the answer for your LCM. Clear? That's it. That was that easy. बिल्कुल इसमें कोई मुश्किल बात नहीं थी. It wasn't that hard at all. That's it. And you are practically done with HCF and LCM. That's it. That is the basic concept of HCF and LCM. Here we go. And we're done.